Hello, everybody. This is a video example of how to graph an ellipse and identify its features given the general form of a conic section. So I suppose the first place that would make sense to start would be, how do you even know this is the equation of an ellipse at all? Well, the tell here is to look at the coefficients on the square terms. So on the x squared term, we have that kind of subliminal coefficient of 1. And on the y squared term, we have a coefficient of positive 4. Now, if they were the same amount, it would be a circle, balanced. But since they're not the same, however, they're the same sign, they're both positive. Positive 1 versus positive 4, it's stretched one way more than the other. So this is indeed the ellipse. So that's how you can tell there from general form. But just looking at this, folks, I would have an immensely difficult time finding where is the center, how big is the major axis, how big is the minor axis, etc. So we need to transform this into standard form. So to do this, I use a process, and my process starts with reorganizing, where I have my X stuff first. I know, very professional there. My X stuff plus my Y stuff. And then I put the constant on the right side. So X stuff plus Y stuff equals constant. That would be the first thing I would do to arrange this problem. So if I grab my X stuff, I have an X squared and a positive 6x. So I'll put that here, X squared plus 6x. Now let's reorder the Y stuff. So that would be a positive 4y squared and a minus 8y. Minus 8y, that's what I call the Y stuff. And then the constant, we have a positive 9 here, but if I subtract 9 to both sides, 0 minus 9 is negative 9. Or you can think when you move it to the other side, it changes signs. Okay, so there is our rewrite. So now we have x squared plus 6x plus 4y squared minus 8y equals negative 9. Okay, so things are looking good. So now we're going to start on a process called completing the square. If you're not familiar with this, you might want to check YouTube for other videos on completing the square. The basic idea is this, and we'll take just a quick pause in the action. So we're going to hit pause on this problem, and let me just put up a thought cloud real quick. The idea here is basically this. If you have a binomial squared, let's say x plus 4 squared, that really means x plus 4 times itself. And if you FOIL this out, first, outer, inner, last, you'd end up with x squared plus 8x plus 16. If you don't believe me, FOIL it out. First, outer, inner, last, multiplication. So basically, the long and the short is this is the same as this. They're just an equivalence or different looks for one another, right? So what we're going to try to do with this problem is we're going to try to create a perfect square trinomial, something that looks like this, then convert it into its binomial squared, something that looks like this, which will give us the HK form so that we can find the center, etc. Okay? So we want to create an X trinomial, a Y trinomial, and then convert it to binomial square. That is how we're going to get this into standard form. So with that analogy in mind, let's see how this works step by step. So let me erase my little thought cloud here. And let's do the following. Let's prepare an X trinomial. So to prepare an X trinomial, I bring down my X squared, I bring down my positive 6x, but I don't have the constant that's going to match with it. So I'm going to put an empty box. okay? And I'm going to put that in parentheses. That's what I call my x trinomial. Now, what's up with this constant in this box? Just stay tuned. We're going to hit that in just a minute. So we're artificially manufacturing manufacturing a trinomial. So now let's work on the y stuff to make a y trinomial. So we're going to have plus, however, if there's a coefficient other than 1, okay, notice that x didn't really have a coefficient. It was at subliminal 1. Since the y squared has a coefficient of 4, we have to factor it out. So I have to factor out the 4, parentheses, since I pulled the 4 out, I bring down my y squared, minus, note, I'm not going to bring down this 8 because I factored out or divided out the 4. So if you divide 4 out of 8, you're left with 2 in y, plus my empty box to create the trinomial, okay? And then I still have equals my constant of -9 on the right side. So we're getting ready to artificially insert a constant number here in the x trinomial and the y trinomial. And in preparation for that, folks, remember that this is an equation, right? It needs to be balanced. The weight to the left of the equal sign has to equal the weight to the right. So if I'm about to plunk down some values here in these boxes, I can't do that unless I plunk down the same weight or values on the right side. So to do that, to make this balance, if I add this maroon box here, I have to add one to the other side of the equation. And if I add this blue box here, I have to add that to the right side of the equation. Everything has to be balanced. I hope that concept makes sense. So now, how do you get the information in the box? Well, to get the constant in a perfect square trinomial, you do the following. You take a lot of people, this is like ax squared plus bx plus c. So a lot of people would call this the b term. So it's b divided by 2 squared, or I like to just write it out in words. Take half of this b coefficient, which is in front of the x, take half, and then square it. Okay? So half of 6 is 3, and 3 squared, 3 times 3 is 9. So 9 goes into the box. Now, since I loaded 9 pounds down this side that wasn't there from the start, I need to weigh down the other side with 9 pounds so that it's an offset. It's a fair offset. Okay? So again, take half and square it. Some people maybe like to say b divided by 2 and then squared. Same thing. Okay, I like it just in words. Take half and then square it. Now, we're going to do the same thing over here. Take your b coefficient, which is in front of the y, the non-squared term, and you're going to take half and then square it. So half of a -2 is -1, and then -1 squared, -1 times itself is +1. So you might get all hasty and be ready to plunk down a +1 here, but that's not true. And this is where students will make a mistake in this case. We had no factored out term in the first x trinomial. However, in the y trinomial, we factored out this 4 right here. So it's not like this is a weight of 1. This is a weight of 1 magnified by this 4. So you have to look if something was factored out. So this 1, its weight is really 1 times 4, which is 4, which is what I have to balance out in this box. So that is the scoop there. So now, as I try to make the analogy in the orange thought bubble earlier, now we're going to take this perfect trinomial and we're going to translate it into its binomial square counterpart. To do that, you take your x squared, the square root of that is just x, and then you take the square root of 9, which is 3, or you can take this middle term again, the b term, and you can cut it in half. So half of a positive 6 is a positive 3. So it works either way, either half of the b term, which is positive 3, or the square root of the boxed c term, 3. Okay? And you think, how can this be? I challenge you, take x plus 3 times itself, FOIL, you will get right back to this trinomial, x squared plus 6x plus 3, I promise. These are fair trades, okay, nicknames for the same amount. All right, so that is the x stuff. Now let's work on the y stuff. Plus, bring down your factor out of 4, and let's change this trinomial into a binomial squared. The square root of y squared is y. And then you can take half of this b term, -2. Half of -2 is -1. Or you could square root the c term of 1. The square root of 1 is 1. But the sign always follows the middle term. So this middle term here of the trinomial was positive. So positive follows in the binomial square. And this middle term here, -2, you got to bring down the negative. Okay, so my idea is just take that middle term there and cut it in half and use the same sign. All right, on the right side of the equation, we just have to get a sum. We just have to sum these up, okay? So it's -9 plus 9, that's a wash, plus 4, we're left with 4, okay? -9 plus 9 plus 4 is just 4. So now this might look similar and more friendly like previous ellipses we worked on. The standard form of an ellipse calls for a 1 after the equal sign, a 1, not a 4. And an ellipse has denominators of a squared and b squared. So in order to get denominators and get this to be 1, the only thing that would make sense to do is to divide by 4. Whatever you do to one side, you do to the other. Okay, like this. All right. So what I'm going to do now, I think, folks, is I'm going to try to shrink this a little bit so that I can fit more onto the screen. So bear with me here. Let me try this. If I capture it and I can bring it up a little bit. Yeah, that's pretty good. Let's try that. So now let's see what we got. Starting with the x stuff, we have x plus 3 quantity squared over 4. There's nothing to simplify there, so I just do a rewrite. X plus 3 squared over 4. Plus, on the y stuff, we have a 4 on the top of the fraction, a 4 on the bottom. Those cancel, so we're left with y minus 1 squared. Now, for the sake of the equation, that's fine there. However, for the sake of graphing, remember, things really don't cancel. They divide out to 1. 4 goes into itself once. So I'm going to put this subliminal 1. I'll put it in yellow because it's not necessary to write in your answer, but it's going to help you graph it. And then on the right side of the equation, we have 4 divided by 4, which is 1, which gives us our constant. So now we have the standard form of the ellipse where features are going to be much more apparent. Starting with the center. So I'm going to go up here. The center is called HK. Okay, so you do the opposite of what you see after the X. I see a plus 3, so my H coordinate is -3. And in the Y parentheses, after the Y, I see a -1. The opposite of that is +1. So folks, I know the center is at -3, 1, which is left 3 from the origin. Pew, 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 up 1. Okay, there's my big, beautiful center. Plotted, great. Okay, so we got that. Let's see here. I think, folks, to make some more room, I'm going to erase. You can always go back and rewind. That's the beauty of YouTube. I'm going to erase everything except the equation now and bring that up so I have more square footage to write here. Okay, let me grab this. All right. Oh no, it didn't. Okay, try again. There we go. Okay, so there's our equation. The center is at -3, 1. Okay, that's looking good. What else might we need to know? Well, we might want the vertices. So to get the vertices, let me write down here, vertices, colon. The vertices are along the major axis. They're the endpoints of the major axis. So I look for, in my formula, the bigger denominator. We have denominators of 4 and 1. The bigger denominator is always a squared, and the smaller denominator is always b squared. Okay? So the vertices are related by a. So if a squared is equal to 4, I take the square root of both sides, and then a would be equal to 2. So since a squared was the bigger denominator, and in this example, it was attached to the x fraction, x is horizontal thinking. So from the center, let me go to purple here. So I'll put this in fact, I'll put this in purple. A equals 2. So from the center, which is this point in black, I'm going to go 2 units to the left and right, because again, we're working on the x fraction here. So that's going to be from the center, 2 units to the right and 2 units to the left. So this is going to be a really small ellipse, but that's okay. So now I know the vertices, and I can mark V for vertices, vertex 1, vertex 2. They're going to be at -1, 2, 3, -5, 1, and -1, 1. Okay, so those are your vertices. We could also say that the major axis, okay, that's the total length, the big way that connects the vertices. The major axis length would be, since it's 2 and 2 each way from the center, that's a total width of 4. So the major axis here would be 4. All right, so things are really coming along. Let's see, what else can we say here? What about the covertices? Covertices. The covertices are the endpoints of the minor axis. They're the endpoints of the minor axis. They're related by b squared. So if b squared is equal to 1, take the square root of both sides. So that implies that b is equal to 1. And let's color code this. How about orange? So I'll put b is equal to 1. And since we're working on the y fraction here for the b squared, that's related to the y, which is vertical. So if b is 1 and that was related to the y fraction, from the center, I need to go 1 up. That's a covertice, or CV, and 1 down. That's another one. So we'll call it covertice 2. Okay. So I also know that the minor axis length is the total distance that connects the covertices, or it's the shorter way. So it was 1 up and 1 down for a grand total of 2. Okay. So there we have it. The minor axis has a length of 2. The major axis has a length of 4. Now I will grab, how about red? I'm going to rough in the ellipse. Okay, this is a small one. It's okay. So there's my ellipse. The only feature that I like to see that I don't see is those focus points, or foci. because that's what really makes this thing tick. You wouldn't have an ellipse without the foci points as I taught in class. So what we will do is the following. We will find them. They are related by the following. Okay, there's a formula that says, let me go over here. How about green? C squared equals A squared minus B squared, where you know that A squared is right here, okay? Remember that A length was the distance each way from the center to either vertex, and the B length was the distance each way from the center to the covertices along the minor axis. So this C value, okay, maybe I'll put a star here. C is the distance from the center to each foci, which is the plural of focus. Okay, so once we find C, we'll be able to write the coordinates of the foci and plot them. So we don't know this right now, so we have C squared is equal to A squared, we do know, that's 4, minus B squared, we do know, that's right here, that's 1. Okay, so C squared is equal to 4 minus 1 is 3, which would imply that C equals the square root of 3. The square root of 3 is the exact value. To get a conception of where to go on the graph, the square root of 3 is about 1.7. All right. So I'm going to attempt to put those into the graph. So to put those foci points into the graph, you have to go along the major axis. Remember, the major axis connects the vertices. So I'm going to put that in yellow. Okay, that's the major axis. It connects the vertices. The foci always have to go on the major axis, that connect the vertices. So if I go to green, from the center, I'm going to go 1.7 to the left, 1 and 0.7. I got to fudge it right about there. There's one focus point. And then from the center, I have to go 1 to the right, 1.7 about there. Okay, without a computer, it's really hard to get this exactly right, but that gives us a concept of where they belong. If you ever put in the foci focus points outside of the curve, you messed up. Okay, they always have to go between the center and the vertices. The more skinny it is, the more close they are to the vertice endpoints. The more round it is, the further away they are. They move towards the center. So finally, what would be the coordinates of these foci points? Well, let's think about it. I'm going to start with the center. Okay, watch this, folks. The center was at -3, 1. So I'm going to put -3, 1, -3, 1. So I'm starting with the center. And then I got to think to myself, from the center, which way did we go to plot the foci? We went to the left and to the right, which is an X movement. And how much did we go? We went square root of 3, which is 1.7. So since the foci are horizontally aligned in this problem, and horizontal is X, I'm going to add the square root of 3 to the X coordinate for 1, and I'm going to subtract the square root of 3 to the X coordinate of the other. And that gives me my coordinates beautifully like that, and exact values too. No decimals, no rounding. So one exact coordinate of one foci is -3 plus √3, 1. That would be this one here on the right, because the plus √3 took us the 1.7 to the right. And the -3 minus √3, that is taking us minus 1.7-ish to the left, that one. So that's it, folks. That's how you get the coordinates of the foci. That's how you get the C value. I went through major axis and minor axis. I tried to go through the whole thing thoroughly. If you work visually with the sketch, I think that informs how the equation works and vice versa. So hopefully this video helps. If you need more examples, please let me know, and it would be my pleasure to help you. Have a great day and good luck with conic sections.